Okay, I'm going to give a very short video on evaluating surface integrals. Because it's really, if you know how to do surface areas, you can do surface integrals just as easily. Why? Because surface areas, they look like this. So this is really just some function of two variables. So this is just a double integral, right? And the hard part is finding the coordinates. And along with the limits of integration. Well, let's compare that with what a surface integral looks like. And it looks something like f dot n, and then we'll have again that RU cross RV. So notice this is again just a function of two variables times du dv. So the only extra step is you just need to find that normal vector. And if you're in the case where it's a sphere or a cylinder or a box, then the normal vector is pretty transparent. So that's not much more different. And again, it's just a double integral. It might be more complicated looking because you have this extra term, but definitely don't get freaked out by the fact it's a surface integral. Just think of it as a surface area, and if you like, just set up the analogous surface area. So in other words, what you could do is you could just say set f dot n equal to 1 temporarily, and then set up the surface area integral. And so that will be the same steps you needed to do a surface integral. It's just that at the end, now you'll want to add in f dot n to the integrand. Right, so my point is, don't treat these things as some kind of new objects you have to assimilate. Just think of them as surface area with an extra term. And just add this term at the end if that makes you more comfortable. Okay? It's just like when we did double integrals, and we thought of dx, dy, dz. This actually gave us volume, but then we just put an extra f here at some point, because this gave us things like centers of mass and probability, expectation values. But really, it's just the same procedure, right? It's just double integration or triple integration.